Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, it is time to bring to you class 11th NCERT chapter number 3, that is trigonometric functions, and today we are going to deal with exercise 3.2 in this session. So let's continue with the first question What does the first question say? Let's take a look at this. Find the values of other 5 trigonometric functions in exercises 1 to 5. Okay. The first one says that cos x equals minus 1 by 2 and x lies in third quadrant. X lies in third quadrant, cos x equal to minus half. And what are we supposed to find? We are supposed to find other 5 trigonometric functions for this angle, right? So how do we go about finding these things? First, I'll tell you a simple approach of solving this question. A simple approach of solving this question, yes. X lies in the third quadrant, so let's solve this. X lies in the third quadrant over here, and which all trigonometric functions are positive, which are negative in this quadrant. When we talk about our ASTC rule, we know that tan and cot are 2 trigonometric functions which are positive in this quadrant, and other 4 trigonometric functions would be negative in this quadrant, right? What else? Cos x is equal to minus 1 by 2, or you can say that if you had a right angle triangle where this angle is theta, cos theta would be half for that matter, right? We'll have to consider the modulus value, the positive value of that. Cos theta equals half tells us that this base length, this base is 1, this is 2. Cos theta is equal to half tells us this. Once you are aware of this much, we can easily find this perpendicular. The length of perpendicular would be hypotenuse square minus s square, which is 4 minus 1 under root, which is root 3. This will be equal to root 3. After you are aware of this much, what you will simply do is write the values. How can we write the values? We already have cos x equals to minus half. Sec x can be easily written as a reciprocal of cos x, or you can note hypotenuse upon this, but sec would be negative, so this is actually minus 2, right? From here or here directly. Sin x would be equal to what? Sin x is simply equal to root 3 upon 2, but there's a catch. Since x lies in the third quadrant, this value has to be minus root 3 by 2. That's important. Cosec x would be reciprocal of this, so minus 2 by root 3. Tan x will be simpler. Tan x, what is tan x equal to? Now tan x over here, as you may clearly observe, would be equal to root 3, but with a plus sign, because this lies in the third quadrant. Tan x is plus root 3 and cot x is 1 by root 3. This is what you get. This is 1 by root 3. Cot x would be 1 by root 3. Now this is a simple approach of dealing with this question by drawing this right angle triangle. And in general, this is what you can follow. But when you talk about NCERT, these people want you to do some calculations and find using some method. Now what is the approach, what is the method that they want in general, and the method which you will be using while appearing for your exams and all in the school only. For JEE purposes, this is something which you'll remember, and this is something which you can use gradually. But when you talk about the school exam purposes, let's talk about that. So cos x equals minus half implies, or the approach which the NCERT people want you to follow is this, that cos x equals minus 1 by 2. They say that there is no need to draw any diagram, any triangle. We could draw the triangle and find the values very easily, but then they say, okay, cos x equal to minus half is something which you know. So on the basis of that, you can easily find sec x. Sec x equals 1 upon cos x, which implies that sec x would be equal to minus 2. That's the first value that you get. On the basis of cos x equals minus 1 by 2, the value that you will get for sec x is minus 2, which is very easy. Okay. Then you will talk about another important trigonometric result, identity. What is that? Something which relates cos x to some other trigonometric function. Now cos x and sin x are easily related by the identity sin square x plus cos square x equals 1. We'll use that, right? Since sin square x plus cos square x equals 1, so therefore we can easily get the value of sin square x over here. So therefore sin square x plus cos square x is minus 1 by 2, the square would be 1 by 4 equals 1, which gives me sin square x is equal to 1 minus 1 by 4, which is 3 by 4. Okay, therefore this will further imply that sin x equals, take the square root, you will get a plus or minus square root of 3 by 2. But since x lies in the third quadrant, which value? Will you take the positive value or negative value? Since x lies in the third quadrant, sine is negative in that quadrant. So since x lies in third quadrant, therefore sine x would be equal to minus root 3 by 2. That's the first, second and third trigonometric function which you have found. Now with the help of this sine x, you can find next cosec x very easily. Cosec x, which will be equal to 1 over sine x, which is simply equal to, which implies that cosec x is equal to reciprocal of this, which is minus 2 by root 3. Now that's the next trigonometric ratio that you obtain very easily. What else? You can also find other two trigonometric ratios which remain, that are, those are tan x. Tan x equals, since tan x is equal to, in terms of sine and cos, you know that tan x is equal to sin x upon cos x. So this is sin x. Sin x is minus root 3 upon 2 whole divided by cos x, which is minus 1 by 2. This gives me tan x is equal to, minus minus will get cancelled, denominators 2 will get cancelled, and what you will get is this. Tan x is simply root 3. If x is lying in the third quadrant, tan x was supposed to be positive. Yes, that's what you're getting. And cot x, which is the reciprocal of tan x, implies cot x would be equal to 1 over root 3. This is what you get. Cot x will be equal to 1 over root 3. Those are the 6 trigonometric ratios. One was already given, second, third, fourth, fifth, sixth, and that's what you get finally. Right? Is that all? Yes, that's the complete solution of this question.